Okay, today we're going to talk about open loop YIG performance. So right now this 8566B is set up for a frequency span of 5.1 megahertz. If you look real closely at the top there, you might be able to see a little bit of wobble on that. What we're looking at is the 100 megahertz cal signal coming into the input of the instrument minus 10 dBm, 100 megahertz. So what we're able to do with the analyzer, just using it by itself, is determine whether or not its open loop YIG is behaving. So right now what's happening is the spectrum analyzer is locking right here and then rolling in an unlocked mode the YIG across. It goes back and locks and rolls, locks and rolls. So the only part that's synthesized is the very first frequency, and then it's an open loop sweep, and you can actually see the YIG wobble a bit because it is open loop. When you go below 5 megahertz, then it won't be open loop and it'll tighten up and it'll stop this little wobble. If you're experiencing a lot of ratty looking display on a clean carrier for spans above 5 megahertz, it might be that your open loop YIG has got some problem with the controls through the DAC or connections, and it's causing the YIG to be ratty. And even though it'll lock, because the lock will clean it up, but the open loop performance is poor and your display for spans above 5 megahertz is poor. If the YIG gets bad enough, of course, it just probably won't lock. But the lock is able to clean up a noisy YIG for whatever reason, and you can get a clean looking display underneath 5, but above 5 megahertz, it's ratty looking. So let's see what happens if we take the span down to 4.9 megahertz. Now, it changed the resolution bandwidth, and we're going to set the resolution bandwidth up. My camera's kind of funky on the focus there. It seems to be finding itself, hopefully. And so now you will not see any wobble in the carrier because now it's locked. For every point in the sweep, it's being locked. Okay? So this is an easy way to look at the YIG, open loop YIG. And if the YIG is really noisy, if you get a really bad display here, you need to address that because it's going to affect the quality of the purity of the lock of the YIG. This is a very good 66B, very little wobble in open loop YIG. They can be a little bit worse than this and still be pretty decent instruments, but you don't want to see much more than about maybe a 20th of a division of wobble when you're at the span of 5.1. Now, the other thing I wanted to talk about is the diagnostic functions, which help you greatly if you're trying to find a problem with your synthesis system, be the YIG or the phase lock loops, the M&N, all that stuff. So if we go shift, marker level, it's going to bring up, unfortunately my camera's not doing a great job here on the focus, but over here in the upper left-hand corner are the diagnostic for this instrument. I'm going to try and come out a little bit, and maybe it'll be a little bit cleaner. It seems to clean it up a bit. Okay, so those numbers, the top is the YIG start frequency. It's at 3.718 gigahertz. The next is the output of phase lock loop 1, 2, and 3, which they call the 2030, and that's at 21.05 megahertz. The next line are the band number, which is 0. The 2 digits are the M&N integers, and those set the frequency coming out of the M&N loop, which is the next number, which is 187 megahertz. So if you look in the manual, you'll actually see a table for the M&N numbers, and you'll find that M&N number should produce 187. So if you think the M&N synthesis is wrong, you can use this to determine which frequency the M&M should be putting out. And by the way, for spans less than 10 megahertz, that shouldn't change. So even though if we go to a locked all the way across, that should be fixed, I believe, at 187. But I'd have to double check that. But certainly, it's most likely not going to move if you get the span small enough. So then the next one is the output of phase lock loop 2, which is 105.25 megahertz. The last is the output of phase lock loop 3, 160.21 megahertz. Now there's an asterisk, I don't know if you can see it, in front of the last line, which is phase lock loop 3 frequency. And that means that phase lock loop 3 is not being used. Because for spans above about 100 kilohertz, I believe, and below 5, the only one of the phase lock loop 1, 2, and 3 that's being used is phase lock loop 2. And that's important because when you're troubleshooting, sometimes you want to get down to the simplest system, or perhaps you only see an unlocked phase lock loop 3 when you go down below 100 kilohertz a span. That's why, because it's actually not used perhaps in the span that you're above that. I should say it's not, but what I mean is that you might see it used if you went up to some other place and set up the instrument in a different way or something. But for spans between 5 and 100, right here, the way we set up the instrument, not being used. 5 megahertz to 100 kilohertz, not being used. So if we take the span down and we just start ticking it down, the asterisk is there, 2 megahertz span, the asterisk there at 1 megahertz, the asterisk there at 500. Now I'm going to put the resolution back to auto, resolution bandwidth. Now we still have an asterisk, we're 500 kilohertz span, and now our 200, asterisk still there. At 100 kilohertz it goes away. And now it's at 164.5 is the very beginning of the span. That's where the phase lock loop 3 frequency is, and it's being used. The asterisk is gone. So this diagnostic is very easy to use. It's access, I should say. It's 2 keystrokes. And it's very useful if you have a problem with the synthesis in the machine to double check what's coming out of the various subsystems. And you can also check the frequency of the LO by just going to your front panel here. I don't want to move my camera. And you can go to your first LO output and monitor that with a frequency counter or another spectrum analyzer and put the instrument in 0 span, and so it's only going to put out that very first frequency that you see there, and it should be exactly that frequency plus or minus the error of your reference oscillators. You can lock them and then you won't have any. And also, if you're using it in 0 span, you might want to shut off your sweep. That because every time you go through a resweep, even in 0 span, there's a slight disturbance to the yig. So if you really want the cleanest output and you want to use the spectrum analyzer as a signal generator, put it in 0 span and turn off your sweep, and now you've got a CW signal coming out of your first LO port on the front of the instrument. If you want to set it up so you can easily command a frequency as a signal generator, you use another shift function, which I'll go into at some other time. But you can find that, and it removes the offset. You have to set the instrument up into the bands where the preselector is used, because the offset is always 321.4. And when you use the shift key to remove that, now you can just enter in a center frequency, and viola, the offset's removed, and you're essentially commanding that frequency come out of the yig if you're in 0 span. Okay? So using the diagnostics is really important. Learning how to look at a spectrum analyzer in the open loop is important to determine whether or not you've got a noisy yig. And you can do it without anything but just turning the instrument on and going through some spans and seeing what happens. Okay.